All right. How are you, everybody? Let's do this. So the second part of lesson 5's, how would we solve this equation using logarithms? So first things first is we wanna solve for x, right? So how would we get x by itself? The first move, notice it's 2 times this 2x. So the first move I want to use is divide both sides by 2. So now that I have 2 to the x is equal to 1 over 2, the idea is for this section, we want to use this little trick of a logarithm that if I have from previously, that if I log base 2 both sides, notice that because these bases are the same here, this cancels. So then you're left just with x is equal to. Now, how would you solve this? 2 to, how do you translate this? 2 to what power is 1/2? So here, x is equal to minus 1, because 2 to the minus 1 is equal to 1 over 2 to the 1. So here, this just becomes minus 1, and it works. And then how can you check this? If you look on the next side, let's plug in this x equals minus 1 into the original equation. So if I have 2 times 2 to the x equals 1, then x is minus 1, right? So then I have 2 times 2 to the minus 1 equals 1. 2 times, this becomes 1 over 2 equals 1. 1 equals 1, check. All right, let's look at the next one. Now this is why, for this question here, you're going to see why this little logarithm trick is very, very helpful for solving certain equations. So let's look at, let's look at the next one, number 2. So here we have 200 times 10x to the 4th equals 100. So what we want to do is we want to divide both sides by 200, both sides by 200. So I have 10x to the 4th is equal to, this is going to be 1 over 2. Now notice that where is the x value? It's as an exponent. So to kind of get rid of this 10, what you're going to have to do is, why don't you pause the video and try and think what would the next move be, right? And now if you want to see what you have to do is, you have to take the log of 10 on both sides. So then you log 10 over here, and then you're also going to log 10 this 1/2 as well. Okay, because here, when you because these two bases are the same, this cancels, right? This is the little trick we've been doing all the time. If they have the same base with the logarithm and the exponential, then it cancels. And then what are you left with? You're just left with whatever the exponent is. So you're just left with x over 4. But here, how would you do this one? How would you do 10 to what power equals 1/2? I have no idea. I don't know what it is. But what I could do is, I could use my calculator, right? So this is what I want you to do, is to use your calculator to actually solve this. So to put in logarithms, it'll be the same here. What you need to do is you hit alpha, then you hit window. And then I want you to go to the location where it says log base, right? You see where it says log base, you hit enter, and notice that it should give you this little option. So here we're going to put 10, and then here we're just going to put 1 over 2. And if you want to put in a fraction, look how you put in a fraction. You hit alpha, y equals, and then you see this n over d. You hit n over d, you hit enter, and then you have the fraction. So you put a 1 over here and a 2 over here and enter. And look at the value you get. You get negative 0.301. So this is negative 0.301, right? And you could just only go to 3 decimal digits. And then once you have this, how do you solve for x? Here you just cross multiply. So you have 4 times this value. So you could just multiply this by, here we could just do 4 times negative 0.301, and that equals negative 1.204. So x is equal to negative 1.204, all right? Now, what we want to do is we want to check, right? Why is this the answer? Let's see. If I have 200 times 10 to the x over 4, this is equal to 100, right? But that's equal to 100 when x is equal to this. So what we're going to do is we're going to plug in this negative 1.204 times 10 to the negative 1.204 over 4. And let's see if this actually works. So watch how we're going to put this into the calculator. First, we're going to see that if I do this, we get 100. Or very close to 100. So here, the first thing is 200, right? Times, now we're going to have a 10, right? And then how would you put in exponent? Because this is to the exponent, right? So we're going to hit this button over here, right? So now notice that we have an exponent. But now we're going to put in a fraction. So you could put a fraction into the exponent, and it's the same way. You go alpha y equals n over d. And if you put negative 1.204 divided by 4, hopefully this gives us something very close to 100. And it does. You see how this value is very, very close to 100? And it's right. So this is equal to 100, give or take, right? And why isn't it exactly 100? Because don't you remember when we got this answer, it was when we got this answer, this negative 0.301, it had other decimals. So you needed the full decimal to get the full 100. But the idea is that it's very close to 100. So 100 is equal to 100. And that's what this squiggly line means. This squiggly line means it's very close. They're very close. So yeah, let's try and do the next. Try and do this one by yourself, number 3. Okay, the same idea we did here. Okay. All right, so now if you want to see me do it, here, what we want to do is we want to get this x by itself. So let me zoom in a little bit. Okay. So now we're going to divide both sides by 94, and a 94 here. So 2 to the x over 3 is equal to 16 over 94, right? I mean, if you want, you could simplify this fraction. But the main idea is, how do I get the x by itself over here? What's the technique we're going to do to get rid of this 2? The same way we got rid of that 10. What we're going to do is, we're going to log base 2 both sides. Because when I log base 2 on this side, this 2 cancels, and then you're left with the x over 3. And then now you have to do log base 2 of 16 over 94. I don't know what this is off the top of my head. 2 to what power gives me 16 over 94? I have no idea. But you know what does know it? The calculator. So we're just going to put in the calculator for this. And what's the idea? You hit alpha, window, you go to log base, and then you put the 2 over here where the base is, then hit alpha y equals n over d, and then you put in the fraction 16 over 94, and then you get negative 2.55, right? So it's negative 2.55. So notice, like, the same way when we checked it, we didn't fully get 100 because we didn't have the full decimal. The same thing is going to happen here, that when we plug in whatever answer we get, it's going to be very close to 16. But let's just keep going on. So this is negative 2.55, and then we still have this x over 3. So then what do? You're just going to cross multiply. What's 3 times negative 2.55? So 3 times negative 2.55 equals negative 7.65. So x is equal to negative 7.65. Okay? And what do we want to do? We want to check it. Here, if I have 94 times 2 to the x over 3 equals 16, then hopefully 94 times 2 to the negative 7.65 over 3, this is your exponent for the 2, hopefully we get something very close to 16. And let's check it. So here, if I have 94 times 2 and the exponent, we're going to put in this fraction, negative 7.65 over 3, right? And let's see, is there a glare? Yeah, there's a glare. Okay, let's see what do we get. And look, it's very, very close to 16, right? It's 16.05, but it's very close. So yeah, it checks. All right. Now let's look at this one. Now this this is the last part of the lesson. Here, E is an irrational number. So E is a very famous irrational number. and it'll equal 2.71. And what this e represents, I'll have to explain in some other class. But for now, let's just see what we do here. Notice that the idea for this, the first thing we want to do is get the e by itself. So strategy, get e solo, right? Because we want to solve for x. So how do we get e by itself over here? We're going to divide 11 on both sides. And now we have e to the 5 over x equals 1 over 11. Now from here, what do you think you're going to do to both sides of the equation? You want to log base e on both sides of the equation, log base e. Okay, because once you log e on both sides, this cancels, and you're just left with 5x equals whatever this is. So we need to do log base e 1 over 11. And what will this equal? Well, same idea, right? We go alpha, window, log base. We'll put a e here. Now, how do you put e? That's a good question. E is found over here. So you're going to hit second, the division symbol. And then you go to, now we need the fraction of 1 divided by 11. And what does that equal? It's equal to 5x is equal to negative 2.398, because I'm going to round this digit. It's 397, but I'm going to round this 7 up 1 because there's an 8 here. Okay? And then how do you find x by itself? You divide 5. So x is equal to this value divided by 5. Divided by, so negative 2.398 divided by 5, and you get negative 0.4796. So negative 0.4796. Okay? And if you check it, it should work that if I plug in 11 times e to the 5 times this, you will get 1. All right? But one thing that we need to understand is the next part of the lesson is that in math, if you log e, it's the same as this symbol. This ln is represented as the natural logarithm. So if instead of writing log base e, you could just say ln of x or ln of whatever. So we'll talk about this soon. That the idea is if I have e to the 5x is equal to 1 over 11, right? You see how we were at this point, and what did we do? We log e on both sides. But what you could do is, what you should do is you could just take the ln on both sides. And if you take the ln, remember the ln is the same as the log base e, and this cancels. And look what happens. You see, when you did log base e, you got this negative 2.398. So if I take the natural log of 1 over 11, I should get this negative 2.398, and it will work. So where is ln on your calculator? Ln is over here. And then if I put in the fraction 1 over 11, watch how, let me delete that. Okay. Watch how we still get that. Look, we still get, if I take the natural log, we still get that same number over here. And we'll talk about that, right? So instead of doing the log e, if you have an e, you should just say ln on both sides. Okay, what I want you to do is try and go through the next questions by yourself. You got this. I'll see you in class.